Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Iqbal and this is Lab 1 for Fluid Mechanics, and I'm going to present to you about hydrostatic pressure. Over the last few weeks, we have covered Chapter 2, and hydrostatic pressure is one of the subtopic in Chapter 2, and I'm going to present to you the lab of hydrostatic pressure. So firstly, I'm going to talk about the introduction. Actually, hydrostatic pressure is related to buoyancy, which is by Archimedes principle. So the hydrostatic pressure is the pressure that exerted by a fluid at equilibrium due to the force of gravity. And this fluid is also known as the hydrostatic fluid. So our hydrostatic pressure lab was to determine the hydrostatic pressure of water on a flat surface by adding weight and then filling the tank with the water to the point where the apparatus was in equilibrium, so that we can calculate the force on the flat surface using the given equations. So next, I'm going to talk about objective and methodology. So about objective, the objective of this lab is to determine the hydrostatic force due to water acting on a partially or fully submerged surface, and to determine both experimentally and theoretically the center of the pressure. Next, we go to methodology. For this lab, in this experiment, the hydrostatic force and center of pressure acting on a vertical surface will be determined by increasing the water depth in the apparatus water tank, and by reaching an equilibrium condition between the moments acting on the balance arm of the test apparatus. The force with create these moments are the weight applied to the balance arm and the hydrostatic force on the vertical surface. So next we go to the figure setup. So as you can see on the left hand side, the picture shown is the tilting submerged quadrant, also known as the hydrostatic pressure apparatus. This equipment allows the moment caused by a fluid thrust on a wholly or partially submerged plane surface to be measured directly. A PVC quadrant, which is the orange thing, is mounted on a balance arm pivoted on knife edges which coincide with the quadrant center. When the quadrant immerses in water, there are hydrostatic forces. The balance arm has an adjustable counterbalance and weight with a hanger. The quadrant is mounted on top of a clear acrylic tank, which allows water to be admitted and drained to a required level by a valve. The tank rests on adjustable footings, and a bull's-eye level is provided. So next we go to the results. As you can see, there are 6 graphs where we can obtain after doing all those experiments. From the data collected, the hydrostatic pressure and distance to the center of pressure can be calculated for both, which is for partially submerged and fully submerged plane surface. And once this is done, the theoretical hydrostatic pressure and distance to the center of pressure can be calculated. And for this one also, we could compare the theoretical value to the actual values where we can measure, and the percent difference is then also can determine. The percent difference between the measured and the theoretical value was almost nearly zero for all increments. We also did have some discrepancy between the measured and theoretical depth to the center of pressure. The percent error of depth to the center of pressure range from 1.79% to 50.42%. Next is discussion. We can see that the force applied in the system vertical face of buoyant material counteracts the mass added to the hanging arm. And we know that if we move away from the sea level, the pressure will change either with air or water. And in this experiment, the change in pressure because of the weight of water above and buoyant forces clearly show the properties of water. And the water pressure was so high that we added the mass 50 gram to 450 gram, and even still the quadrant was able to support it in static equilibrium. So the idea led us to believe that the curved area allows for a larger surface which the water can act upon for less change in depth. So here is the conclusion. The analysis that our lab shows is a linear relationship between hydrostatic force and average depth for the partially submerged, and the graph of hydrostatic force and average depth for fully submerged, which is also linear. and our theoretical force compared to the measured force is very nearly identical. And the error in the distance to the center pressure compared to the theoretical was outrageously high, with a percent error of 50.42%. The graphical analysis show a linear relationship between hydrostatic force and average depth for only fully submerged. And lastly, the graph of hydrostatic force and average depth for partially submerged is not perfectly linear.